Hello and welcome to our session delivered by SecurityHQ on security orchestration, automation and response tooling and how you can use that as part of your incident response processes to accelerate and standardize your responses to common threats and risks. I'm here today with my colleague Nilesh Burgate, who leads our intelligence team over in Pune. And my name's Chris Cheyne. I'm the SOC Director here at SecurityHQ, and I'll lead you through the session today. So a little bit about us at SecurityHQ. We've been doing SOC-based services, managed detection and response type of services for the last 14 years. So a lot of experience spread over 6 global security operations centers in every continent. We've got 250 analysts continuously delivering that 24/7 detection and response services to help our customers defend themselves against complex threats and allow them to deliver security to their businesses. We've been using security orchestration and response tooling for quite some time now. So we've got a good handle on how best to use it, where it makes sense and where it doesn't make sense. So we're really going to focus on that today. Now, automation and SOC technology is a bit of a buzzword in the security marketplace right now. And I guess the question you should be asking is, why do you care? What challenge is it actually trying to fix for me? So we thought we'd just start by articulating some of these challenges so you can see whether it's actually a problem that you have and that you need to fix. So the first issue is, incident response in general, it's a 24/7 problem. Okay, so cyber never sleeps, something's going to go wrong, and it's going to go wrong at the most inconvenient time. So the question there is, where can we use orchestration and automation to help that place? Second issue is that a lot of the analytics that we do around security intelligence gathering or investigation analysis of incidents, it's way beyond the human scale to be able to do that type of work in an effective way. Gathering intelligence, ingesting that data, crunching it, and spitting out an answer that an analyst can understand. Third issue is the need for speed. Our adversaries are using automation and that sort of tooling against us in a very programmatic way. So that means that you need to scale up to be able to defend yourself in a way that at least competes against that level of automation. So the need to be able to detect, analyze, and then respond to something in seconds is absolutely critically important. Need for speed. Next issue is around heterogeneous systems. Okay, so we might all be migrating to clouds, whether it's AWS or Azure or Google cloud environments. But inevitably, we're going to have heterogeneous systems, lots of different security tooling out there that needs to be orchestrated, lots of different OSs and applications and so on that need to be spoken to and talked to. So we've got multiple different systems that we need to be able to communicate with. Next issue is a lack of skill. There is a significant lack of security expertise and skill, particularly around the high-end incident response and forensics type of activities. So anything that we can do to leverage technology that will make it easier for us to consume that information, make decisions without having to be that forensics or incident response expert it's a good thing. Next thing is really around consistency. So being able to do something repeatable today, that doesn't matter who the analyst is or the engineer that's doing the activity, they will do the same thing as the guy will do tomorrow and the day after that and the day after that, and I can audit it. Consistency is everything in security. I've got to be able to account for the activities that they do and be confident that we'll do the same thing again tomorrow. And that leads to making sure that we can clear pathways to clear decision making. When a bad activity happens, we should have a clear direction about what we need to do as the next steps. It needs to be documented and it needs to be auditable about making sure that we've got clear decision pathways in place. And then the final thing, well, it's not really the final thing, but another significant thing is around the complexity of some of the incidents that you might be dealing with, have multiple vectors, multiple attributes associated with them, multiple IOCs, all multiple stakeholders. So the issue here is complexity is magnified because of all those different factors, and you need a way you can bottle it and deal with those. So SOAR, Security Orchestration Automation Response Tooling, is going to definitely help with that if you can build playbooks and workflows around those sorts of issues to help deal with them. But a good starting place is to sort of really understand where that's all going to fit into an incident response process. And a place to start is to look at the NIST incident response framework that breaks things down into the preparation, detection, response processes, and then lessons learned. Where does automation and response tooling fit into that? Well, first of all, detection analysis is one of the first parts of it. You might have an EDR tool or a SIM tool or any other different analytics systems out there that's going to give you an alert to say something bad has happened, I need to do something about that. Analysis comes next. It's often the case that we need to enrich data, we need to be able to search additional log data, intelligence archives, or query other systems. That analysis, enrichment, absolutely SOAR is going to help us with that. So use case number one we need to talk about. Second thing is around containment. So I would like to be in a position as a customer where if I know something bad is going to happen on an end user workstation or a system, I want to be able to isolate that workstation, suspend a user account, block the IP on a firewall, or the email domain or URL. So to be able to do that in a programmatic way with automated containment actions is, it's a peace of mind, and that plays into that incident response process. So the point is, it's not the be all or end all. This is not going to fix the entirety of our incident response plan, but it is a weapon that we can use to help with analysis and containment, and then the humans can come in and do the eradication recovery type of work, which could also have some automation in there as well, and the systems that we have around detection. So it's got a part to play, but don't be fooled into thinking that we can automate our way out of incident response. That is a fallacy. It cannot be done. It's only part of the overall picture. So next I want to talk about two different response processes that we can use that are largely modeled on one of the most incredible defense systems, which is the human body. And that is the reflex, a reflex action, a human reflex action, and also a human response action, because those two things are really what we're trying to model in a security operations center to respond to a particular threat or problem. And it's a good analogy to start with. So the first thing that we'll start with is a reflex action. So a reflex action, first of all, is a completely automated action that, there's no human brain involvement in here. This is the central nervous system working to respond to a stimulus that says, this hurts, I'm going to move my hand away from something, or whatever the case may be. It happens instantaneously or near instantaneously. We're talking about measured in milliseconds. And I'm talking about things like a burn reflex or a pain reflex or even blinking, for example, as a reflex. There's no thought process going into that. There's no calculation. It's a simple policy built into the human body to say, I put my hand over a flame, I sense something that travels up through my arm to my central nervous system where I have a motor reflex that says, move my hand away. No thinking involved. Those sorts of policy-based decisions to act something is where we can start to talk about automation. So use case number one. Use case number two is really where we're talking about those more complex response processes where we've got calculation involved with that. So here we've got a symphony of neurons working together to do calculations and decision making, and involving muscles and movement and so on to actually create an actual response process. So think in terms of an emergency stop procedure in a car. You're calculating the distance between you and the object in front of you or the car in front of you, how fast you're traveling, the actual action of moving your leg to press the brake. All of these things are working in harmony together, and they involve your brain and multiple functions there to actually orchestrate that type of action. We can look at the same thing, if I was to throw a ball at you, or in this case, this example on the screen here is a football. So great analogy for the Euros. You're a goalie there, someone's kicked the ball at you, you're calculating the trajectory, you're seeing the ball with your eyes, it's going to your frontal lobe, you're calculating the speed of approach, you're identifying where you need to move your arms and legs and where you need to be in a certain position in time. That is a complete response action that's got multiple moving parts. By far and large, that analogy is going to be far more useful to you in a security operations center incident response type of setting, because most things are not black and white. You need to be able to do some analysis, calculation, and enrichment, and then come to a decision about what you need to do next to take an action. So responses versus reflexes. There's a place for both of those within a security operations center, and underlying all of that could be your SOAR platform, your orchestration automation response platform that's going to help you with both of those two actions. So moving on to putting those into a SOC setting, starting with a reflex. Let me give you some examples of what that can be. We're talking about zero-touch policy-based decisions. For example, if I have a connection to a known bad IP, I've got threat intel that says that IP out there, it's a malicious one. I want to be able to block that connection. I should be able to fully automate that without any decision making, because it's a known bad threat actor to say block that IP. Policy based, happens in milliseconds, no decision making involved there. Of course, we need to follow it up with investigation and analysis, but in terms of threat containment, decision is done. Another couple of examples, I could have credential leakage that I've identified using any intelligence systems that I might have that says these credentials, I've seen them on the dark web, suck that into the system, automatically push an action to disable a user account or reset his password. Doesn't necessarily need a human involvement at this stage. Of course, it needs a human involvement thereafter, again, to do the investigation. But policy-based, make the decision, block it, it's a reflex. And we can go on looking at multiple high severity security events on a single host within a certain amount of time. We could say, that's bad, I'm gonna just isolate that host, make it safe, zero trust type of environment. I will then follow up with a proper investigation. So those reflexes can work, but you will fast run out of those type of responses that you want to push with just simple reflex and simple automation. And then you'll fast want to move into more orchestrated type of activities, which is the next example. So here, when we're saying automation versus orchestration, orchestration is really about integrating with multiple different systems and enrichment of data. Decision making, decision trees involving human analysts. Maybe there's whole points involved where we have to make a human analyst make a decision about whether we go down path A, B, or C in a decision tree type of environment. So we're orchestrating a playbook for incident response. There's going to be far more of those that you'll have to contend with on a daily basis. First example, phishing incidents. Sounds simple. Phishing incidents, your email security gateway has identified a risky type of email. It's maybe a bit of a gray issue whether that email is a legit sender or not. Maybe it's failed a couple of security checks like your DMARC or SPF or something like that. And you need to make a decision about whether you need to delete that email or take any other action on that. That's going to require a whole decision tree and analysis to enrich the data with threat intelligence, go and search log archives on whether there's a historical sender type of activity with that. And then decision trees about what to do next. Do we go ahead and delete the email? Do we go and inform the user? That's an orchestrated process. And that will happen every day of the week. And I think we can all agree that phishing is a risky activity that we're all going to be familiar with. Another example is looking at log-on activity from an unusual location. So I've got a first-time user access from either internally to a critical server or externally from an abnormal geolocation. It doesn't necessarily mean that's a completely rogue user, but it is something that is suspicious. So if I'm able to detect that, what I then need to do is be able to correlate that with other user type of logs. What is that? What are we seeing on the AD? What are we seeing in the proxy firewall endpoint systems associated with that same user? Pulling together all that information and making a decision whether that is just an abnormal, legitimate event or whether it is something which is outright malicious, and we need to then take an action, maybe to suspend the user on the Active Directory or isolate their machine. So that decision tree and that analysis is proper orchestrated response. I think far more useful than reflexes in terms of saving human effort, accelerating the speed of response, and getting a consistent answer as to whether something is good or bad. So reflexes and response, you need both of them, and decide where you need to use it. I'm now going to hand over to Nilesh, who's basically going to go through some more granular details and put some meat on the bones in terms of how we can use those processes and some playbooks around some of those examples. Nilesh.
Let's take an example of a phishing email investigation to really understand the difference between cyber response and the reaction part. A phishing email comes, anti-phishing system detects that it's a phishing email, and immediately you go for a reaction, which is either block that domain onto the email system, at the same time block that IP address on your firewall systems. And even go ahead and ask the users to change their password. So that's the reaction, because the emails are detected as a phishing by our anti-phishing system. But the real life phishing attacks doesn't happen that way. They are always sophisticated. The attackers will always find out the ways to bypass the email filtering system, as well as identifying new ways to get into the network. The easiest one that they will do is to use the IP address which was never involved in any of the phishing attacks. Okay, so that beats your threat intelligence system. Second thing that they will do is to spoof the domain ID of the organization which they are targeting. Now, for spoofing also, for spoofing, there are a lot of email security protocols that has been invented by the industry, which is SPF, DKIM, as well as DMARC, to really identify the spoof email addresses. This is how the organizations can protect themselves. The third thing that we can do to detect such kind of an advanced phishing email attack is to check the behavior of an email ID. There are a lot of keywords which gets blocked by anti-email systems, but those keywords can also be easily bypassed by putting a keyword in your own in a foreign language, or maybe by forgetting that that keywords into an attached keywords, and which is the easiest way to bypass the systems which relies heavily on the keyword. Now, most of the sophisticated attack phishing emails that we have seen are not detected by any of these systems, which is bad domain IDs or the spoof email controls, or maybe the keywords also. What they do is they mimic the email which looks like as if it is coming from the known sender. Now, this is also the case where which is the recent attacks like your supply chain attacks, which the easiest one, the example is of the SolarWinds, where the attackers will not target the main organization, but they will do the attacks indirectly by coming through your supply chain. Okay. This is also we have seen in a lot of investigations that we are doing, which we call it as a credential harvesting. Once somebody's email gets compromised, then the same email box is used to send a phishing email to all the known people of that compromised email account, and the chain continues. So because you receive that email as if it is coming from your known source, you tend to open it, you tend to reply to it, and you tend to supply the information to it. Okay. So that tells you about the behavior. So all these are data points, which is known behavior as well as unknown, as well as some of the suspicious behaviors are the data points that goes to the that are available to the SOC analyst, and this is where he uses all this information to make a decision whether it is a known phishing attack or it's a false positive. A lot of the advanced phishing attacks are also using the technique called as sending a malicious URL or sending a malicious attachment into the phishing email. There are a lot of anti-email APT systems which will do the analysis of all these URLs to confirm whether those are malicious URLs or not. They will also, if it's an attachment, they will also it will be detonated in a sandbox to really check the behavior of a attachment and then make a verdict. Now, even those can be bypassed if it's a really determined and a sophisticated attacker. The easiest way, and this is also we have done in some of the red team attacks that we do. The way to bypass is that we know that all such checks are coming from the well-known email filtering systems like from Microsoft, like from Google's, Cisco's. Okay. So you collect all these IP addresses, and whenever such connection come from those known sandbox IP addresses, you show a behavior which is genuine, which is a benign. And if it's not coming from any of these IP address, then the phishing attacker will actually show the right behavior, which is to either download a malicious ID or read out the user to the website, which looks very similar to Office 365. Sometimes we also seen in a credential harvesting attack that the website, the login website, which looks which looks exactly like the organization's website with the same logo and the look and feel, which is exactly the same. Okay. Now, when the SOC analyst is doing the email investigation, is collecting all these data points. Now, these data points are used to make a decision. Now, this is the response part, right? Now, he's not only relying on the known factors, but the unknown factors which are collected, which are analyzed. Based on this, he's going to make a decision to confirm whether it is a phishing email or a false positive. Now, if it's a phishing email, then he's going to take an action like blocking the IP address, blocking the domain. If there are indicators into our SIM that somebody has clicked that URL or somebody has even responded to that email to that URL, malicious URL with the credentials, then we can even disable that user account. At the same time, we also have to ensure that we clear the cache or the session, so that the attacker who already is in possession of those active sessions will not be able to use that email accounts for further doing the phishing email attacks, or even get involved into the credential harvesting attack. Okay, so these are all the multiple checks that are performed. So there are some of the actions which are automated, but the most important part is taking an informed decision based on the information that is gathered from multiple sources, whether it is your firewalls, email systems, and also the proxy system. So this is how the response part is taken care for things like phishing email investigation. Now let's go back and understand how the SOAR technology supports in cyber response as well as the reaction process.
Now that we discussed the difference between cyber reaction versus the response part, let me reiterate the benefit of cyber automation and orchestration. The biggest benefit is minimization of duration to detect the attack and therefore reduce the impact that the cyber attack could cause. It also helps to optimize the current cyber processes so that the SOC and the analyst knows as what they are supposed to do when such kind of a event or such kind of a cyber security attack happens. With the automation part, we are also able to get threat intelligence from multiple sources. So that really helps us to know that what really is happening, and at the same time connect the dots for any bad actor from multiple sources. Because of these playbooks that are predefined and at the same time customized for the organization, the team will be able to respond to any cyber attack with accuracy. Now, all this automation is possible when we go for a commercial SOAR product. Some of the capabilities that the SOAR technology should have is ability to build complex playbooks, so that we can put multiple conditions, connect to multiple log sources, collect the data, and while this data collection is happening and take decision. There could be some decisions which are automated. There are some decisions which waits for the SOC analyst confirmation. So all this complexity we should be able to customize those playbooks. Another important capability is the visualization, wherein the SOC can see what exactly the attack is evolving, what are the different dots that it is connecting to. It should also have the capability to connect multiple heterogeneous systems, IT systems which are on-prem, on cloud, at the same time the different security solutions. Now, the dashboard part is very important because the SOC team as well as the SOC managers are looking at the dashboard. So the dashboard has to be meaningful. That will help the teams to really understand at which playbook is currently going on, what is the status of each of this each of the playbook, and at the same time which incident needs more attention so that the resources can be arranged accordingly. The SOAR also has the capability to produce report based on the multiple matrices that you can define. This really helps you to then identify how efficient the teams are in detecting this attacks. At the same time, how efficient the team is in terms of responding the cyber incident. Some of the matrices that the SOAR technologies can support is mean time to detect as well as mean time to respond. Okay. Now at SecurityHQ, we have implemented IBM Resilient as a SOAR technology that really helps us to automate and also build orchestration for a lot of most common cyber incidents. At the same time, some of the complex one like the ransomware attack or the supply chain attacks. With this, we are able to automate with intelligence, collaborate with our internal team members as well as with customers with consistency, and respond with confidence. Now let's quickly go through these capabilities that the SecurityHQ has. We are able to automate a lot of action that really is going to help the customer to detect the incidents, at the same time take actions quickly. Okay. Now, for this, we have built use cases which are highly customizable, but at the same time, with our own experience, of understanding the cyber attacks in details and understanding the nuances, the complexities that it can have at each and every step. What we also realize is that we are working on an ecosystem. There are multiple log sources. There are multiple technologies that gets involved. Some of the information is quickly available, whereas for some of the information we have to wait for those queries to execute and respond back. While all this is happening, we want our SOC analyst to ensure that whatever data point that he has collected so far, he's able to take some decisions, and at the same time he's able to take actions like containment actions as well as a responsive action, so that the impact of the attack is reduced. Now all this information that is getting collected, we have to ensure that the teams are working with other team members, like L2 has the visibility, and there are some parts which L3 is taking care of. So there is a division of tasks between the teams, and this is important because we want to respond. To the threat faster. Now, whenever there is an attack that has happened, you really want to ensure that where all that attacker has reached so far. What were the actions previous to the attack, and now what is the action that he is planning to take. So all this is possible when we are integrated, when the SOC team member is collaborating together. Now all this collaboration, and there will be some actions which will be dependent on the customer side, and the customer also has to internally coordinate for the containment as well as the responsive actions. Because these playbooks are now pre-configured, the SOC team member knows what are the steps that they have to take for every condition that is coming up. They know what could be the subtask, as well as what are the additional conditions that they have to check before confirming the type of the attack, the severity of the attack, as well as the steps that they need to take to respond to the attack which is consistent, which is already been accepted, and which has already been accepted, as well as has been discussed with the customer. Now there will be some incidents where we also need to, where the customer has to respond, has to update to his partners, or maybe to the regulators. With this automation, we know what kind of information has to be passed on to the regulatory authorities. All this can be pre-discussed with the customers, and whenever such incidents happen, we know that we are passing on to the right information, and the customer is also confident that whenever such incident has happened, he's getting the information which he then can use to pass on to his management, as well as for the regulatory compliance also. Okay. Now, how this is done? into the client environment, I will briefly discuss about that. On the left-hand side is the SecurityHQ's SOC infrastructure, which includes the IBM QRadar on the top, which is our SIEM that is connected closely with the IBM SOAR, which is resilient. And at the same time, we have System X, which is the SecurityHQ component, which is our proprietary component that is a part of the whole SOC operations. On the right hand side are the client, and the client has multiple technologies, like he will have his own firewalls, VPNs, Active Directory, Office 365, which is a cloud, and as well as the EDI technologies. Now all these are different technologies which are going to get involved in majority of the cyber attack, and there are actions that each one of these technologies can help to really contain and respond to the attack. So the way it works, we will be connecting to each of these technologies either by connecting directly with the shell. Say, for example, for firewalls, we connect with SSH protocol, so that we can run the query, we can run the commands directly onto the firewall or to the VPN. Some cloud technologies like Office 365 or if it's a case of Azure Active Directory, then it's an API integration. Even with the EDR, it's API integration. So as soon as the attack happens, some of the actions that we can take, of course, those actions will be performed depending on the agreement that we have with the customer, either in an automated way, or we wait for the customer to confirm as what action has to be taken. So this the integration works like this, that for firewalls, we can take the actions on, like blocking the IP address or the domain, or maybe even go to the level of isolating the machine so that it doesn't talk to any machine onto the network, or it doesn't make any connections to the internet. We can even block some of the users from the VPN, so that on the fly basis we can say that okay, any connections from specific countries will be disabled for the time being. Or if you identify that somebody has logged in from multiple locations at the same time, which looks like a suspicious activity, then we can even go to the level of disabling the VPN access for that user. Active Directory, we can take actions like disabling the user or if the user is showing the suspicious activity, then we can change his privileges from the administrative account to the normal user accounts, or even go ahead and disable the account. Office 365, we can delete the phishing emails remotely. We can block the domains onto the Office 365, so that all such phishing emails get blocked from the domain. The most important part is the EDI technology, where we can take the immediate containment action, like isolating the machine, or isolating multiple machines which are involved into the cyber attack. So this is how the implementation goes in for the automation as well as the orchestration process. We have already tested. Our team has experience of integrating with majority of the technologies, and this has been tried and tested. So the team has experience of integrating with multiple systems.
Okay, so at the moment we're offering a 30-day proof of value or proof of concept where we can take the customer through a complete experience of what a security operations center service is, what the MDR service is, from onboarding to operations, and allowing that operations to continue for a month. So you can see a full monthly cycle in terms of the weekly reporting, the real-time analytics, the incident handling, the dashboarding, the granular reporting as a complete experience. So we're offering it at the moment. We've had a good uptake on that, and it gives customers an opportunity to see what this is all about. You know, it's not a technology; it's a complete service proposition that gives the ability to have the end-to-end visibility, real-time detection, and people on hand to respond to problems on the fly as they happen. So I think we see a lot of customers reporting a lot of value from that, and inquire with the Bytes team if you want to take that up. You're welcome.